Before we begin, it is extremely important that you set up P3D and the MVAMS to your desired settings. P3D and the MVAMS need to be run as administrator to work properly. Go through the MVAMS and the manual that is included to make sure that your settings are correct. Here's a cold and dark pit. Let's start going through the flow that works for this simulator. Nose gear door is closed. Emergency flap is normal. Avionics activation panel switches are off, except for nav and comm. Those are set into backup mode for this demo. Throttles are off. Yaw damper is off. Flaps are up. Backup TACAN is on. Fuel cutoffs are normal. Flaps are indicating up. Audio switches as required. Countermeasure dispensers and master arms off. Uncage the standby ADI and set 3 degrees nose down. Engine electronics display is on. Backup comm and VOR/ILS is on. Boost pumps on. Battery and generators on. Pitot heat and engine anti-ice off. Lights on for immediate startup. Let's open the 2D panel with Shift 2. Here we can select external air, external power, select flight crew, and travel pod. The MVAMS pre-flight utility also has provisions for GPU toggle, GPU air start 1 and 2. These options are also available in the add-ons drop-down menu. Going through the warning lights, there are 2 fire lights just beneath the glare shield. The warning/caution/advisory panel items trigger the master caution, which can be extinguished with the push button. £250 is the fuel on board when the fuel light comes on. Engine start can commence now. Apply external air with your preferred method. At 12% RPM, push the igniter button and move the throttle from the ICO detent. Within 360 pounds per hour of fuel flow and 12 seconds light off should occur. In an event of an in-flight spool-down shutdown, windmill at 12 to 27% for a restart. Use the igniter buttons or move the throttle into max. Both engines power the flight control hydraulics. The right engine is started first when no ground power is available. The left engine powers the utilities, which are gear, speed brakes, wheel brakes, yaw stab, and nose wheel steering. The utility system can power flight controls as well. Turn on the multifunction display and upfront control panel. Start the left engine similarly. Disconnect external connections. Let's continue with backup mode navigation. Turn on the embedded GPS INS. This provides attitude and location data at all times. The frequencies and channels are visible at the bottom of the display. The VOR ILS panel can show radial and bearing info as well. The TACAN panel is here. OBS can be set with the rocker switches. Note that the navigation sources have their individual colors. That's all there is in the backup mode. Continuing with normal startup, place the mode knob back into normal and turn on Mission Display Processor and TCAS. While they're booting, lower the flaps and check the indicator. Cycle the flight controls. Move flaps into 60% position and set takeoff trim. Enable the yaw stability augmentation.
Caution, caution.
Retract the speed brake. In the lower right corner is destination point 200, which is where the EGI was aligned initially. Normal navigation is done with the HUD, upfront control panel, and the multifunction panel. Starting from the upper left corner, the airspeed indicator with a yellow mark for maximum gear down speed of 240 knots. Next to it is the altimeter. The accelerometer is below it. At full fuel, the max is 5.7 G, and at 1,000 pounds, 7.2 G. The angle of attack has green marks at maximum range endurance and optimal approach. Once again, the nav sources are here. The first thing before entering any data is to decide if the data set in MVAMS is desired. The data transfer cartridge data is loaded here. Going back into navigation displays, the map mode can be changed. Using the declutter options can be very handy. As a final check of EGI accuracy, check that status is nav and other data is correct. On the control panel, enable the radar altimeter, and if the status happens to be other than nav in the data window 4, change it. For communications, we may pull up stored presets. For manual frequency tuning, UR4 followed by the numbers and enter works out.
7 Celsius. Altimeter 2996 Kilo Whiskey Yankee Sierra Automated Weather Observation 1238 Zulu. Wind calm. Visibility greater than 20.
Now the altimeter baro setting is put into UR2. The 2 and 8 keys are an alternative way. UL2 sets the standard setting. Altitude warnings are available. Presets can be changed. They show up in the list. The increment, decrement diamond can be moved around with number 5. Moving on to navigation. The easiest way to head onto an airfield is the nearest feature. The current steer point is in the bottom corner. This selection also activates the divert mode automatically. The course and distance for the current nav mode are in the upper corner. The EGI nav data block is always in the lower corner. The destination page provides a selection to disable the divert mode. The time on target feature can be accessed here. Stored flight plans can be reviewed. Waypoint 00 is always the initial location. The most important setting here is the steer point type. Flybys and initial approach fixes can have a farther lead point within 7 miles in auto switching mode. Airports and missed approach fixes disable auto switching. Only ICAO waypoints support auto mode, e.g. named waypoints. Having selected a waypoint from the flight plan, it is activated. The FPL page has review functions as well. TOT with an offset, for example, local time may be set. Starting from the basic page, the EGI source can also be selected from the EGI subpages. Some sources, such as Localizer Back Course, can only be selected here. Having selected Auto Steer Point Switching Mode, radio navigation is set up. Manual tuning for TACAN and VOR is always required. Check the UR4 selection for which of TACAN or ILS is used for the DME. Time on window 3 is the reference for flight plan TOT computations, generating an airspeed bug on HUD. Otherwise, this can be used as a stopwatch. The IFF page allows for normal transponder operation. The FL button provides an alternate graphics for traffic. Now that preparations are done, start rolling out. Tap on the brakes. Hold down the nose wheel steering key/button if it is set in the MVAMS. At the minimum, turn on pitot heat. Line up properly. Once engaging afterburner, the NWS is disabled. Setting current heading on the bug can be done by double-clicking UR1. 300 knots is selected on the speed bug, which is the desired minimum maneuvering speed. Selecting the next waypoint on the flight plan resets the course. Run the engines up to mil power or 98%, 630 degrees. Commence rotation at about 145 knots. Pitch to around 10 degrees. Clean up before 200 knots. Accelerate to 300 knots with 5 degrees flight path marker. 0.8 Mach is a decent rule of thumb for climb speed. Heading to steer point on course. Visible moisture is a good reason for engine anti-ice. If preferred, the climb dive marker mode can be disabled for the ADI, e.g. remove the FPM. Flight director can be enabled with UL4 or with the button above the ASI. Map mode can be cycled while it's airborne with the default display switch. Display range can be cycled with the MMS nav button press. Approaching the steer point, the FD commands a turn and the course is reset. Adding a waypoint starts with selecting the preceding waypoint after the new one from the flight plan. Selecting a manual course is an option. Here, steer point is designated to be overflow. Setting a TOT sets an airspeed command. The remaining plan is taken into account. Enabling the divert mode gives speed and altitude on an unrestricted profile. The range and endurance modes calculate results for current altitude. Be mindful of the steer hold. The other remaining FD mode besides heading is the heading to course. It allows manual intercepts angles instead of 90 degrees with the heading command. We're at Randolph AFB. The aircraft has the ability to display a combination of coordinates as zones and no-fly zones. The zones can be patterns such as nearby racetrack routes and so on. Zones are set up in the MVAMS. The no-fly zones are represented by circles. Individual zones can be toggled on the MFD. Air-to-air training is on the board, so a destination point is located in the middle of a training area. 401 is going to be designated as in the EGI. It's also going to be set as the bullseye, which can be referenced on the HUD and MFD. Use the master mode switch to select between air-to-ground, nav, and air-to-air modes. Air-to-air is selected and the change is present on the right side of the MFD. Master arm is set to on. The two gun sight modes are funnel and lead computing optical sight. As the 38C lacks a radar, the LCOS reticle has a fixed range. The funnel has a setting for wingspan in feet. The aircraft has entered the training area. Another aircraft is approaching. This TCAS mode displays relative altitude in hundreds of feet. The symbol changes and resolution advisories are given if required.
Descend, crossing, descend, descend, crossing, descend. Clear of conflict.
In the FL mode, intruder's altitude is shown in hundreds of feet.
Descend, descend, descend. Clear of conflict.
Turn performance can be categorized as instantaneous and sustained. The best instant rate in degrees per second occurs at maximum G, which itself can be limited by AOA or structure. The sustained rate happens at around 0.9 Mach. The rate begins deteriorating at 0.5 Mach. Using a low yo-yo in order to gain lead pursuit. Firing the gun should occur when the target fills the funnel. The target is maneuvered by the VRS TACPAC drone function here. Rolling into lag pursuit to preserve energy for saddling up. Loaded rolls are the swift way to lose energy. Don't roll and pull G simultaneously. Now back to the full flight tutorial. Whilst cornering, the initial approach fix on this approach is a bit similar to ILSY or LOCRWY19 at Jackson Hole is tuned manually. The VOR is switched into primary EGI source with the NWS command. Its course is set. The flight plan remains on the background. Cycling back to EGI and resetting the FD. ATIS frequency is tuned with the preset. The self-contained approach stores preset setups. Here, The frequency and course is reviewed for the ILS-19 approach. A rule of thumb distance for a 90-degree turn is 0.5% of ground speed. The turn is initiated a bit too early here, and an overshoot follows. A better option would have been to set a manual course line and follow it before selecting VOR mode. A destination waypoint could have been created for the terminal fix because they aren't supported. The SCA approach is activated. A reciprocal heading to runway is set because of later circuit work. A better implementation of the 0.5% rule is executed in capturing the localizer. Lowering the gear brings up the AOA symbol in a bracket. Top of it is slightly fast and vice versa. Maximum speed for 60% flaps is 230 knots, and 210 knots for 100%. With the gear down, the final approach speed for the current configuration is automatically shown. It is 160 knots for 1,000 pounds of fuel or less, 1 knot per pound for above that. If you use a 3-degree glide slope, delay easing back on the throttles. Rate of descent are to be less than 500 FPM on touchdown. In go-arounds after touchdown, lower the nose from landing attitude. Maintain at least 200 knots in the crosswind turn. The island on the horizon is about 1.5 miles from the runway center line. The yellow line is the final turn speed. The green line is the computed final approach speed. The overhead approach begins at 300 knots and usually 1500 AGL. The HUD can be decluttered as desired. The ground track feature is utilized, which can be handy in crosswinds as well. Bank to 60 degrees. Maintain level flight throughout the turn. As the wings are being leveled, extend the gear at 1.5 G max. Back to the first approach. In the perch position at 45 degrees from the runway, roll into a bank of around 45 degrees. Place the flight path marker into about 5 degrees dive. Maintain on-speed AOA minimum. Adjust bank angle, pitch, and power for proper positioning. It's very easy to exceed full flap limiting, so be aware of your airspeed. A nifty way to approach is using a shallower glide path of about 2.5 degrees. Use the pitch ladder for that and/or the 3 reds on the lights. Aiming for the threshold gives time for the flare-out. Begin reducing thrust about 1,000 feet from the threshold, aiming for idle power at touchdown at slow AOA. After touchdown, use 10 degrees pitch for aerobraking. In a go-round, retract the speed brake first. Lower the nose into less than 10 degrees pitch. Retract the flaps to 60% and use max thrust if necessary. Another form of SCA is a form of computer-generated lateral inversion guidance. It is loaded like the ILS SCA. The approach symbology is the cross, which denotes an FAF. The circle, with a diameter of 5 miles, tangents the approach course at the FIP point. For maintaining position on the arc, less than 240 knots is required with a bank of 30 degrees. The HUD type can be changed. The default is the F-16 style. The FPM is drift compensated, but it can be disabled. The MIL standard type, or F-22, can be used if desired. The approach waypoints are sort of like destination waypoints. Accordingly, they need manual coordinate input. The values can be found in map programs. Check for the correct coordinate format. For altitude calculations on a 3-degree glide slope, use the 300 feet per mile rule. In this case, the FIP is 12 miles from the runway, thus at around 4,000 feet above the runway elevation of 6,500 feet. The FAF is 9.3 miles away, therefore around 3,000 above the runway. As you pass the FIP, the SCA mode switches into final and GS guidance begins. For a minimum run landing, aim at the threshold. 10 knots below the calculated speed is used with a slightly slow bracket. The thrust could have been reduced while arriving over the threshold. A slower touchdown could have enabled a quicker pitch up to 12 degrees. Passing 100 knots, lower the nose and start braking. An analog brake access helps in modulating the force. That's it for this round of tips and tricks. Visit the forums for more and, more importantly, enjoy the module.